Hello, everyone. Welcome to our session today in the Virtual Innovation Days. And today I am going to talk about advanced sealing technologies for semiconductor processes. So my name is Murat Gulcur. I am Material Development Manager for Semiconductor segment. I am based in Trelleborg Sealing Solutions in the UK. And you can see today's agenda on the screen. So I'll start giving some introduction about semiconductor industry, and then we'll jump into our perfluoro elastomer or FFKM material portfolio, and then we'll talk about some test results, and then I'll introduce you two of our new products, and then we'll summarize everything afterwards. Okay, let's start talking about semiconductor industry. So semiconductor industry is really unique. It's because it evolves a lot faster than any other industry. That's mainly because we need more computing power. We don't use our mobile phones for 10 years. We change our electronic devices every couple of years. We need new computers. We need new TVs, and especially with the cars and other high-tech devices. Processing speed is extremely important. So because of that, we need the semiconductor industry needs to be fast. So of course, in order to make the microchips faster, the number of transistors in a microchip must grow. So therefore, bigger number of microchips or transistors must be fabricated in an extremely small area on a microchip, on a silicon wafer. So that makes it really complicated. So additionally, dealing with extremely small features in semiconductor industry, that makes the end products extremely sensitive, because we are talking about 5 nanometers, 3 nanometers. These are a lot smaller than what we can see with our eyes, even with standard microscopes. So therefore, everything even the particles we can't see in air, or when we breathe out the small particles, they're all really poisonous for semiconductor manufacturing. Another unique thing about semiconductor industry, it is non-standard. So for example, processors, they all do the same thing. They do processing the data. And if two different companies manufacturing processors, their manufacturing steps can be completely different. So because of that, it is non-standard. So exactly the same product can be made in different fabs, because all of them they have their own IPs, and therefore completely different processes can be used. So because of that, it is non-standard. So now let's see how Trelleborg Sealing Solutions can just answer to these challenges, these semiconductor properties. So first of all, we are really responsive. So in Trelleborg Sealing Solutions, we offer short lead times. Whenever we receive a technical query or a price or commercial query, we respond extremely quick to save your time. So additionally, we have capabilities to offer really wide range of products in our advanced materials. So I will talk about some of them later in my slides. And also, we are knowledgeable. We understand the semiconductor challenges, trends, and what is needed from an elastomer, from a plastic, and we can just help you with the right approach. And finally, we are also flexible. So as I said, semiconductor industry is non-standard. So because of that, a lot of benchmarking tests must be done because there are no material specifications accepted in the semiconductor market. So because of that, we do quite a lot of testing, and we share all of these test results with our customers to help them save time for manufacturing new or advanced semiconductor processes. So let's talk about finally the trends. We are all aware of these. So the semiconductor trends, wireless communication, now 5G on our mobiles, in our life. It is available in most of the developed countries. Automotive, mainly autonomous driving. because quite a lot of data processing and data, sharing with the servers is needed for autonomous driving. So computing power is extremely important. And also artificial intelligence, Internet of Things. These are all things that, makes our lives easier, and we demand for it as end users. However, developing all these trends, all these new devices with new properties, that also creates some manufacturing challenges for manufacturing microchip, which I meant. For example, miniaturization. As I said, the transistors should go just smaller and smaller. It becomes extremely delicate. Device complexation. So when two-dimensional area is not really enough, the semiconductor engineers, they're just thinking of going in 3D structures. And of course, all of these new microchips, these new semiconductor innovation must be accessible for everyone. Therefore, higher yields, therefore lower prices for microchips is needed. So finally, all of these manufacturing challenges for microchip makers, and also it brings some trends, some another challenges for us as sealing or elastomer supplier to semiconductor industry. For example, higher temperature operations, higher plasma resistance, particulation requirements, lower outgassing. So we all know what translates all these manufacturing challenges into, and we prepare ourselves accordingly, and we do quite a lot of testing, and we share all these with our customers. So now let's jump into excuse me, with our Isolast PureFab material portfolio. So we launched these materials a little bit longer than a year ago. So far we've got very good feedback. PureFab JPF10 is our general, not really general purpose, but fully organic material, which is developed for high-end deposition and plasma applications. JPF20, the second material, is our plasma resistant grade, which can resist extremely harsh plasma conditions. JPF21 is our high temperature, ultra high purity grade, which combines high purity and high thermal resistance. And JPF30 is our problem solver, extremely high purity, quite soft material, which can be used in locations, for example, when the elastomers have very close proximity to the wafers which are processed. So these are 4 materials, but of course these 4 materials not enough. So we had some complementary additional materials we have developed, and these materials will be launched this year. Some of them will be launched in next year. So PureFab JPF22 is another FFKM, perfluor elastomer grade. It is also manufactured in a clean room environment, like the previous 4 materials, like JPF 10, 20, and 30. And JPF 22 is our chemical resistant general purpose grade, which is developed to resist against very harsh wet chemicals, mainly for wet applications, wet semiconductor applications. JPF 40 is our ultra high purity grade, where extremely high, thermal resistance is needed for RTP or, similar thermal applications. JPF 40 is to go-to material. And as you can see on the right-hand side, we have 2 FKM grades. These are not FFKM, but they are still manufactured in the clean room, and they have very, very clean formulations, VPF 10 and 20. So we developed these materials to use in locations where FFKM's chemical resistance or plasma resistance is not really needed to save cost and increase the cost of ownership. Okay. I spoke about 8 materials, so now you might be a little bit confused which one does what. So I just tried to summarize in 2 simplified graphs You can see here temperature versus chemical resistance chart, and JPF22 clearly it has very high chemical resistance. Its temperature rating is up to 250 degrees. However, it's not really needed for wet applications. Most of them below 100 degrees anyway. And as you can see, JPF40, JPF21, and JPF10. Other materials that can be used in 300 plus temperatures, and JPF30 and JPF20 are rated to 300 degrees Celsius. So another chart for you here to understand. So this is purity versus plasma resistance. So two materials, as you can see on the right hand side, stands out, JPF10 and JPF20. So we recommend JPF10 material for deposition applications, mainly because of its market leading outgassing properties. And JPF20 is mainly recommended for very harsh plasma environments to use in, for example, valves or shower heads, that kind of location. So this is a summary of our PureFab material. So, and again, I'm mostly talking about elastomers right now, our Isolast PureFab range. So they are elastomers, they are rubber materials. So when elastomers are, subject of a conversation, I mean, they are used as seals in most of the cases because they have, very good viscoelastic properties. So when we talk about the seal, mechanical properties, of course, very important. How long that seal is going to last, how, what's the compression set, how the material recovers, as well as the chemical resistance and chemical compatibility is extremely important to, to determine the lifetime of the seal. In semiconductor industry, on top of mechanical properties and plasma resistance and chemical resistance, there's another requirement, which is purity. Because, as I said, the diffuser size is, going down below 5 nanometers, which means that, it is extremely delicate. Therefore, trace metal content, the amount of metallic impurities, outgassing is extremely important, and as well as, not releasing any molecules at higher temperatures, another way of outgassing. So we have done all of these testing, even we've done more than what you can see on the screen, and I'm going to share some of them today for you to have an idea about how our materials, especially PureFab materials, compare. As I said, elastomers are mainly used for sealing applications, and you can see the most important property of an elastomer when talking about sealing performance, which is compression set. So compression set is the amount of permanent deformation after some time at a constant temperature. So you can see two charts on the screen, 200 and 300 degrees Celsius, in both cases, we've done this test extremely long. Actually, we have even longer test, up to, I think, 4,000 hours. So you can see all of the materials still, they don't deform too much. So lower the results, better the performance in compression set. So you can see at 200 and 300 degrees, our materials can last, can retain their sealing performance really long times. So now looking at these graphs, maybe you are a little bit confused, because JPF10 in both 200 and 300 degrees, it has the best performance over long period of times, and you might say that JPF21 and JPF40 is rated a higher temperature, and why is that? So this graph answers that question. So JPF10 works perfectly until 310 degrees. After 310 degrees, its properties start just going up. As you can see, the compression set results at to 320 degrees. It is extremely high, and it doesn't really survive any temperatures about that. But JPF21 and JPF40, as you can see on the right hand side, they survive a lot longer, especially JPF40. It can resist up to 350 degrees, even maybe slightly higher, but we don't really want to push the limits, because this is about the recommended maximum operating temperature. So this is only to demonstrate, even if there's a temperature incursion, to 350 or 340 degrees, these materials can really withstand those extreme conditions. Another important property is purity. So I told you about how delicate semiconductor manufacturing is, and you can see purity. One way of checking purity is trace metal content. So we have tested our own materials, final molded O-rings. By the way, these results were measured in external labs, and you can see the complete the whole 30 metal trace metal data in parts per billion. So it is nanogram per gram scale. And you can, there's nothing to say, I think, here why we named PureFab materials pure, because they are a lot cleaner than the competitive materials, which are very well known in the market. You can see on the right hand on the screen. So now let's talk about outgassing. Outgassing is another important property which is mainly needed for high-end deposition applications in semiconductors, such as ALD, PEALD, or PECVD kind of applications, deposition, thin film deposition methods. So outgassing is extremely important because we are talking about 2-3 nanometers. In the near future, those will be commercially available, and even a small molecule released from an O-ring or in the any component of the chamber, they can really have bad effect on the yield. So you can see again on the screen the outgassing performance. So this is RGA, residual gas analysis. By the way, this is partial pressures were measured. You can see two competitive materials, they are quite high, and previously we had Isolast J9675 material, which has been used in high very extreme locations where low outgassing is needed. It has been used, but even our new Isolast PureFab range, it has even better performance than our best material which we had in the past. So you might even say here, most of the outgassing is coming from the moisture, so that can be get rid of. So here I just put the volatiles and non-volatile contents on the charts. You can still see JPF10 and other PureFab materials that have extremely low outgassing. So we are quite comfortable to say JPF10 is the market leading material in terms of low outgassing. Okay, now we spoke about the materials, some properties, and but we are a sealing solutions provider or elastomer solutions, polymer solutions provider. So therefore, material is extremely important. However, the design of the product is also equally important. So when material and design comes together, it forms the product. So in Trelleborg Sealing Solutions, we combine the capability of manufacturing complex parts and superior materials, which I spoke about some of them, to create innovative sealing solutions where we help with our customers to improve the cost of ownership. So here, the product overview for semiconductor segment. So we spoke about elastomers, of course, the O-rings and static seals, gaskets, for example. So we offer Isolast FFKM PureFab material range. They are all manufactured in the clean room. They are washed and packaged in a clean room environment. We can also offer FlexiMold. FlexiMold is our technology to make extremely large diameter O-rings. So without needing for a tool charge. We also have some other flange seals, which I'm going to talk about. We can also offer quite complicated engineered parts, for example, rubber to metal bonded or rubber to plastic bonded. Again, I'm going to talk about some of them later in my slides. And in rotary seals, especially for vacuum pump applications, we are really market leader. So we have quite a good range of Turcon, Varolip, PTFE seals for mainly rotary applications. So other than all these sealing products, we can also offer advanced composites. for metal replacement, for example, quite high, stiffness composites we have in our portfolio. And we can also injection mold or machine some thermoplastics like PEEK, PTFE, all this kind of, PPS, all of this kind of engineering plastics we can make custom-made products out of these. So this is the product overview, and let's see how elastomers just fit onto the onto a dry processing system, like you see on the screen. So we can offer dynamic seals and static seals. They can be rotary, or just, for example, slit valve doors. We can offer slit valve doors as well. And for static seals, most of examples are like chamber seals and some like gas seals. So we have quite high chemical resistance of our Isolast PureFab grade, so they can also be used for sealing process precursors and gas seals, especially for ALD and deposition applications. Each inside the chamber, actually, each arc protection is another important application for us, because the elastomers are very close to the wafers. Therefore, the contamination, purity, particulation is extremely important. But JPF10 and JPF30 can solve all these problems. So, and on top of these, we can also, of course, provide subfab vacuum pump and subfab components. I'm going to talk about our KFab seals in a moment, actually right now. So KFab flange seal. So we have launched this product just a couple months ago. So KFab flange seal can be used in vacuum or exhaust lines, and they fit onto all KF or NW type of flanges, where normally centering rings are used between two metal rings. So Isolast KFab can be used on exactly the same, because it fits on the standard groove, standard flanges. So they can be used, KFab seals can be used in vacuum piping systems, exhaust lines, rough pumps, abatement systems, so vacuum valves as well. So they have quite wide range of applications in subfab applications in semiconductors. So let's summarize what are the benefits and features of KFab. So first of all, because of its puzzle-shaped shape, cross-section, you can see it is quite complicated design. So it has the ability of mistake-proof assembly. For example, when the flanges, two sides, are not 100% parallel, standard centering rings can cause a lot of problem leakage. However, the KFab seal compensates that unparallelism between the flanges, and it is a lot more efficient. So as I said again, it has quite long service life, because it has double sealing profile, and also because of that clever design. When it is compressed, the puzzle feature, it just acts as a retention mechanism and increases the sealing force. And of course, we replace some of the mass of this seal with metal. You can see on the outer ring. So that also helps with the expansion of the seals, especially at higher temperatures. So KFab seals, they don't really overfill, or they don't extrude at high temperatures because of the expansion. And finally, high temperature capability. So because this is a product we can make in any material that we have in our portfolio, we can make in ultra high purity materials where high purity is needed, or other standard materials. We can make in ultra high temperature materials, so we can go up to 327 degrees, for example, especially in the exhaust line. Sometimes temperatures can go about 300 degrees, so that is quite critical. So this summarizes everything about KFab seal. Okay, now finally I'll talk about plastic bonded seal. So this profile. You can see the cross section on the right. That is our wafer seal. So this peak bonded elastomer FFKM seal is used in electrochemical deposition application, mainly for ECD applications. It seals the back of the wafer from the nasty chemicals and deposition solution. So here the advantages we provide on this product. Normally, I mean, non-TSS products, non-Trelleborg products have the problem of delamination after some usage. So that really reduces the lifetime of the part. But we have developed our own bonding retention mechanism. So the elastomer bonded on the peak, it doesn't laminate quickly. So we have quite advanced technology there. And by using that technology, we can also maximize the wafer surface to be processed. So the edge exclusion is just minimized to maximize the wafer surface for microchip manufacturing. So another advantage of this wafer seal is that it doesn't stick onto the wafer. Some elastomers, or most competitor elastomers, I can say, when the wafer goes down, as you can see in the video, it sticks onto the wafer, and it causes quite a lot of problems, wastage and time consumption there. But this wafer seal, it doesn't stick on the seals to maximize the performance. So just to summarize, so we offer sealing solutions for high-end semiconductor applications. I've spoke about KFAB and wafer seal. So we lower the cost of ownership, we increase PM cycles. We would like to work with you together to find solutions for your custom problems. And also Isolast PureFab materials, they have excellent plasma resistance, and in terms of purity, you've seen against the most common competitor materials, they are really high purity. And the outgassing, again, especially Isolast JPF10 is market leading, and all of the materials have very good high temperature performance. So this is all I'd like to talk about today, and I am going to take some questions from you. So I'll just check on my screen here. Okay, we have one question. What kind of shapes are these materials typically molded onto? O-rings, gaskets, etc. So I mean, that's a good question. So as I summarized in the product portfolio slide, we can mold in pretty much any shape, unless it is like very chunky, very big, because then curing of the elastomer may not be very easy. We can mold any size O-rings by using our FlexiMold technology, or we can use we can mold gaskets. We can mold them or laser cut them. So depending on the use, so we can also bond on metals, plastics, etc. So we have no limitation on the shapes. Okay, so we have another question about the manufacturability of these materials. We are designing different kind of vibration isolation system by using viscoelastic materials. Can these materials be vulcanized to a metal to use them as a damper? Yes, they can be used, and they are being used. Actually, we have a very niche semiconductor product, which our materials in combination with metals are bonded, molded together to be bonded, and they are used as isolation of isolation dampers. So yes, they can be used, and if you can just get in touch with your local team, we are more than happy to help with that. Okay, let me see another question. So maybe we have one or two question more. Okay, can you do compression set test in plasma to determine the lifetime of a seal accurately? Okay, so that's unfortunately the reality in the lab when we do testing. We do compression set tests to determine the lifetime, or CSR tests, compression stress relaxation tests, in atmospheric pressure. Unfortunately, we can't do it in plasma. However, we do the plasma testing separately, and our simulation engineers, they have developed quite advanced seal life prediction modules. And they can take that, etch rate data into their simulation module, and they can calculate the lifetime of a seal in a plasma environment. So if you get in touch with us, we can of course share more details. So maybe one more quick question. We have limited time. What other substrate that can you bond your elastomer? So as I said, rubber to plastic, rubber to metal, most of the engineering plastics, most of the metals, we don't really have any issues, high purity metals, or just we can do surface treatment, anodization. All of those can also be done. So we are just out of time. Thanks a lot for your time today, and if you have any questions, please feel free to approach our local team. Thank you very much.